All right, so we are starting our statistics unit. On Friday, you guys collected data of 60 of your students. If you weren't here on Friday, you do need to collect your data. You need to collect it quickly because your homework tonight involves that data, okay? You just need 60 students' information, their gender, their grade, their shoe size, and their height. And the homework for over the weekend was to convert all to one unit. Did you guys do that?
Yes, ma'am.
Okay, if you did not do that, that means you just added a little bit of extra onto your homework. And then, yes, for those who weren't here on Friday, yes, you also need to do that as well because you need everything to be in the same unit. All right? So we're going to be doing different things with that data throughout. So it's pretty much going to be a continuation thing. Sometimes your homework will be practice problems. Sometimes it will be working on this basically unit-long project, okay? So please make sure you stay up to date. Make sure you bring your notebook with you every class period. So today we are talking about classifying data, frequency tables. We probably won't get to histograms, but that's all right. We'll just save that for Thursday. So on page 43, you need to title it Classifying Data, and you need to make sure that you guys get down your goal. We're going to be describing different types of data because you need to know what type of data you could potentially be working with. And we're going to be creating frequency tables and histograms. So let's start out by classifying your different types of data. We're going to take the goldenrod color sheet that you guys trimmed up along the perimeter, correct? All right, this is where we're going to be taking the notes for classifying data here. Now, we need to make sure we're working on the skill that you'll need in college, which is taking smart notes. You don't need to write down every single word that's on each one of these slides. You just need to get down what's important, okay? And a lot of times the reason why I put complete sentences up there is, for one, if somebody's watching me on mute on the video or something like that, they can at least read the sentence and it makes sense, okay? And also so that when I read the slide, I don't sound like an idiot. But you yourself, you don't need to write down word for word everything that's on there. Get what's important, okay? Let's practice that skill starting now. And also listening as well, okay? If there's something else that's important that you need to write down and it's not on the board, write that down. So there's two types of data that we are dealing with when you're dealing with collecting data. You have qualitative and you have quantitative data. Qualitative is the type of data that is categorical, such as you take a survey of people's favorite color, or you take a survey of people's favorite candy bar. That is an example of qualitative data. Okay, you place it into categories. But quantitative data, that's the type of data that is numerical, such as, collecting a survey of how many hours students spend studying a week, or students' GPAs and stuff like that, okay? Can everybody understand the difference? You got qualitative is the categorical, and then quantitative is the numerical, all right? Now, with quantitative data, there are two different types, okay? Because when you think about things that are numerical, you got things that you got two different types. The first type is discrete data. And discrete data is data that can be counted or data that can take on a specific value. Okay? An example of that would be the number of people who prefer tea or coffee, or shoe size, or hat size. Okay? That's discrete data. Even the number of fish that are in the ocean, that's discrete data, okay? Even though the ocean is very large, and that would be a lot of fish to count, but we can actually sit there, drain the ocean. We could sit there and we could count all the fish. It might take us a while, but we could do it. But then there you go, you got discrete. It can be counted, or it can take on a specific value. The other type of quantitative data is continuous data. And continuous data is data that can be measured. Okay? It basically takes on a value within a range. An example of that would be weight, height, time. Okay? It takes on a range of values. It's measured.
Wait, so why would shoe size not be that? You can measure it.
Because shoe size is either going to be a 9 or 9.5 or 10 or 10.5 or 29 centimeters or whatever. But your height and your weight, it takes on a range of values. Okay, it is measured. You step on a scale, they're measuring your weight. Same thing with a height, they're measuring that. All right. Questions on the two? Yes?
So continuous data, you can think of as like a line graph versus discrete would be just individual points, kind of like a scatter plot.
I'm going to say yes for right now, but later on in the unit, you're probably going to interpret that completely different than scatter plot and stuff. It's going to be, but for right now, that will definitely work. Take the white sheet that has those examples. Okay? There are 8 examples that I want you guys to do right now. I'll give you about a minute and a half, and I want you to go through, read each one, and I want you to state whether you think it's discrete or continuous. Okay? So I'll give you a minute and a half. All right. Who thinks they got an 8 out of 8?
I think so.
Like that. Have that confidence, okay? Think about it. Is it counted or is it measured? Okay? Does it take on a specific value or does it take on a range of values? Okay? So the number of sweets in the packet. It is discrete, okay? You can sit there, you can take that bag of Skittles, pour it out in your hand, and say 1, 2, 3, 4, 5, 6, and that's how many Skittles are in your package. What about the heights of students in grade 8? Continuous, okay? It takes on a range of values. The dress size of a girl's pipe band of our Scottish unit. The girls' dress sizes.
Discrete.
This one is discrete, okay? It takes on a specific value. You look right now at your pants, right? You're either wearing a size 4 or a size 34 or whatever. That takes on a specific value, okay? A specific value. The number of red cars in the parking lot. Discrete. I can walk outside that door right now and count the number of red cars. Okay, a specific value. The weight of kittens. Does take on a range. The marks, in other words, the points, obtained by grade 7 in a science test. Discrete. Yes. You either get a 96 or you get a 52. Okay, it takes on a specific value. The times taken for students to write their world literature paper. Continuous. Time is always continuous. And the last one, the number of heads when a coin is tossed 60 times. Discrete. How do we do? 8. Good stuff. Okay? Questions on that? All right. The last little bit of data that you guys are going to be working with. Okay, so you have qualitative and quantitative, and then you have the 2 different types. And it will ask you, is this data discrete or continuous? And you're going to state that. That'll be like a part A in an A, B, and C problem. Okay? So you gotta definitely need to know that. So when you're doing a statistical investigation, the whole group, which you collect, is known as a population, right? So like right now we have 1,525, I think, kids here at Lake Wells High School. But a sample is a small group chosen from that population. So on Friday when you guys went around and you collected all your data, like your heights and shoe size, you took a population of Lake Wells High School. That's what you did. Make sense? Okay? And so there's 2 different types. You can either have a random sample, which is where each element has the same chance of being included, or you got a bias sample, which is one that's not random. Okay? So I ask you, because I wasn't here to kind of ask you guys questions when you guys came back because I had to leave. What classrooms did you go into to collect your data? Who were the teachers? Gilmore, Nichols, Medlock, Austin Moreno, and some random people in the hallway. Now that's interesting. Austin Moreno, Gilmore, Medlock, and Nichols. Every single one of those are what teachers? IB. So did you collect a random sample or did you collect a bias sample? A bias. Because more than likely they were probably teaching an IB class. Right? Huh? But if you went to Auburn, Auburn teach, what does Auburn teach?
Like government or something.
Government, history of some kind. I think Ruckus and Gilmore are the only history teachers on the IB side. So, that would make your sample a little bit more random because you have a different, technically it's a whole different school. Non-IB is 1721, IB is 1722. So you would have a random sample. You see the difference? Okay, so let's see. You got 4 questions on that same paper that you're going to answer. Is it biased or is it random? For this one, I'll give you 1 minute. Determine if it's biased or random. So let's see how we did. When researching if people eat breakfast, only interview the people in the canteen. There are going to be certain things in the IB world because it is an international type thing that there's going to be some things that are going to expect you guys to know. Okay, and even if you've never even dealt with certain things like this before, you're still going to have to know them. Canteen, anybody know what it is?
It's like the area that you sit in, the food there. I don't know.
To my understanding, the canteen is a place like where you go eat, like a cafeteria.
Oh, I thought it was like I was thinking of like a real Western place.
No. It's basically like a cafeteria. Okay, where you guys go there. So it's a canteen. That's usually known in like military. Okay, that's what their mess hall is basically called. All right. So is that random or is that biased? That is very much biased because you can ask people outside what they ate for breakfast. You can ask people in the library what they ate for breakfast. So yes, that's very much biased. But when researching sleep spending habits, interview every third person you meet. That's very much random. Okay? It is random because it could be, one person walk by you, second person walk by you, hey, third person, how much you spend? All right? When researching spending habits on cars, Josh interviews men exiting the garage. Very much so, because women buy cars too. And when researching the sleeping habits of children, Adam distributes a questionnaire to students in his school.
I think it's biased because you could ask people outside of your school.
Exactly. He didn't say the sleeping habits of children at Polk Avenue Elementary. It just says the sleeping habits of children. So this is very much biased. This is very much biased. But we're doing sleeping habits of children. That could be any all children. All right. So questions on the type of data that we're going to be working with. So all this is going to go on page 43. Flip over to page 44, and you're going to title that one Frequency Tables. And this is where the canary yellow foldable is going to go. This is where the canary yellow foldable is going to go. So on page 44, title it Frequency Tables, and then these words are on the yellow foldable. So we're looking at the canary yellow foldable. So whenever you're dealing with a large amount of data, like for example the 60 pieces of data that you guys collected, right? It's easier to organize your data into a frequency table, okay? Now, a frequency table tells you the number of times an event, a category, or a group occurs, okay? So a frequency table tells you the number of times an event, a category, or a group occurs, all right? So, looking at this example, all right, it says the number of sweets in 24 packets is shown below. Okay, it's shown on your page below, and this is actually a 23, not a 22. Okay, so it's a 23. All right, we're gonna make a frequency table with this data. Okay, now what you guys see here is your frequency table. It outlines in the first column the numbers that are present in your data, the tally marks to help you kind of keep track of this data, all right, and then the frequency. Now, normally in a frequency table, that tally mark column is not even there, okay? The tally mark column is kind of like if you were doing a sample and you were standing outside and you were like, hey, what's your, say you already had your numbers written down and you just wanted to see how many people, had a size 7 shoe size or had brown hair, something like that, right? So then you just do your tally marks to kind of keep track of how many people walk by you that have brown hair. And then you would add them up at the end, and then you write down your number that corresponds to how many people you see instead of keep changing the number from 1, then to 2, change it to 3, and so on and so forth, okay? So normally a frequency table does not have the tally marks. It's just there to kind of help you, okay? So it's a quick way of keeping track of, how many you have. It's a quick way of doing that. So, basically all you do is you just go through your data and you see, okay, well, how many number 20s do I have? Well, I have one here. None on the second row, none on the third row. I got one on the fourth row for a total of how many? 2. So this basically is letting you know that the number 20 shows up 2 times out of this data? Oh, Jesus. Thank you. All right. Let's go 21. 21 shows up 1, 2, 3 times. So that has a frequency of 3. So 21 shows up 3 times out of my data. You see how this goes? Can you guys finish off the frequency table for me? Okay. And then we'll check, of course. Now, one way you can check to make sure that you did it well is that we had 24 packets, right? Your frequency numbers, this column should add up to equal 24, okay? So let's see how well you did. How many 22s did you have? 12. There were 12 22s. How many 23? And how many 24? So, let's see. That gives you 2 plus 3 is 5, plus 12 is 17, plus 5 is 22, plus 2 is 24. So, yes, you had all 24. So that's another way to check to make sure that you had it. You know that you interviewed 24 people or 60 people. Your total should have to be 60. Sound good? Okay. Do this one on your own. So in this one, the number of games played in matches at a badminton tournament are recorded below. So you have all your games. Did anybody count how many games there were? There are 22. Of course, you always want to kind of count, you know, unless, especially if they don't tell you, so then that way you can make sure that the numbers you come up with actually adds up to be 22. Okay? How many 8s were there?
6.
So there were 6 8s, which means that M should have been 6, and there were. What was N? How many 10s were there?
3.
There were 3. 3 10s.
Will it ever ask you to like show that N equals like 6?
Not in something like this. This something that's like literally like it says write down M and N, so there'll be like, you know, minimal work here. Okay? All right. Now these are your more basic frequency tables. Okay? You know, where you just have, you know, whatever your data is that you're collecting and your frequency. All right? The other type is a frequency distribution. On page 45 is your green foldable, the frequency tables one, okay? Now this one incorporates the other frequency tables, okay? So you can title this one frequency tables continued, frequency distribution tables, either or, okay? But this one is the green foldable. All right? Now, this one really is going to test your listening skills to make sure that you guys can get that good old skill down before you head to college, all right? So, to start, the question asks you, what's a frequency distribution? Okay? This one's different from the other ones that we just did on page 44, all right? But a frequency distribution, it's still a table, okay? It's still a table that's going to show classes or intervals of data, okay? So frequency distribution is still a table that shows classes or intervals of data with a count of the numbers of entries in each class. So it's still a table that has classes or intervals of data. So instead of it being, you know, like 20, 21, 22, 23, it's going to have intervals. Okay, so it's going to be a range of values. Okay, with a count of the number of entries in each class. So it still has the frequency column. It still has the frequency column, but it includes, it's basically for a range of values instead of one set value.
You said with the count of entries?
The number of entries. Mm-hmm. Now, frequency distribution is also known as a grouped frequency table. So you may hear me refer to that. The question may ask you to complete the group frequency table. They're just talking about still a frequency distribution. Okay? And what you see on this example here is an example of a frequency distribution. have your classes. As you can see, it is an interval. Is an interval 1 to 5, 6 to 10, 11 through 15, so on and so forth. And then it has the frequencies as well. This is basically saying that, okay, for numbers 1, 2, 3, 4, and 5, any one of those numbers within that interval showed up 5 times out of our entire data. The numbers 6, 7, 8, 9, and 10 showed up 8 times amongst our data, okay? Now, this is really used for if you have like a range of values, so like continuous data that has decimals or something involved, or you just have like a lot of numbers. And trying to list out each individual number and put its frequency would be ridiculous, okay? So, your classes, yes?
With, like, is it always going to be in numerical order like it is?
Yes, it will always go from smallest value to the largest value, all right? And so these are your classes. Every single one of these are your individual classes. How many classes do we have? So, yeah, we got 6 classes here, okay? Now, using a little bit of inductive reasoning, what would you say is our lower class limit?
26 to 30.
No, not 26 to 30.
1 to 5.
Not 1 to 5. Lower class limit.
Oh.
I still don't get it.
So lower, which would be a low, on the low end, class, an individual class, and a limit. It is these numbers right here. 1, 6, 11. Because each individual class has a lower number and a higher number, right? So the lower class limit would be those numbers that are on the left side. Like, I'm not going to sit there and circle every single one. I'm just going to do that. So then the upper class limit would be the 5, the 10, the 15, so on and so forth. Okay? Now, what would you say is our class width?
Oh, they did the in between, like from 1 to 5.
No, it says class width. Now, remember, we have 6 classes. So then the width would be
4.
Yeah, 4.
4.
Yeah, but 1 to 5 is 4.
1 to 5 is not 4. 1 to 5 is how many?
5.
5. 1, 2, 3, 4, 5. That's 5 numbers. The next class, 6, 7, 8, 9, 10.
5.
So it's 5. So the class width is 5. So that means that each class size has 5 numbers within it.
When do we ever start counting?
Hmm?
We count.
Mm-hmm.
So
These
1, 2, 3,
are.
4, 5, not 2, 3, 4, 5.
This is inclusive. In this case, it's inclusive. You are including the 1. If you weren't going to include the 1, then they would have written it as a compound inequality, which we're going to do for the next example, because this is just one way to represent a frequency distribution. And the last one is range. Now, second period knew this, so I'm pretty sure that you guys know this too. This goes back to your days of statistics when you were in elementary school. Range. What is that? It is the highest minus the lowest, but you're going to have to be a little bit more specific. What numbers are we doing?
30 minus 1.
It is 30 minus 1. Your range is your maximum value minus your minimum value. In this case, it's going to be 30 minus 1. It is not our frequencies. Our frequencies tell us how often these numbers show up. So it's never going to involve your frequency. So what's my range? 29. All right? And it's important that we identify what all these things are, because when we have to create our own, we need to be able to distinguish what is our lower class limit, what's our upper class limit, what is our range, what is our class width, and of course, how many classes that we're going to be dealing with, okay? So, your guidelines for constructing a frequency distribution, okay? There are some guidelines, okay? And this is also going to be helpful because your homework tonight is you're going to have to create a frequency distribution for your heights and your shoe sizes of the data that you guys collected on Friday. So again, if you haven't collected your data yet because you were absent or something like that, you got to make sure you get that data in, okay? So the first step, we're going to determine the amount of classes you would like to include in your frequency distribution. Normally, a lot of the problems that we're going to be working with, the classes are going to be between 5 and 15. Okay? So a lot of times they're not going to be no less than 5, but no more than 15 when you're looking at your frequency distribution. All right? So once we figure out how many classes we want to have, and that's a choice that you make. That is a choice that you make. Again, I say. All right? Then you're going to find the class width. So you got to figure out how big of a, based off your classes, how big are your intervals going to be. And so to do that, you're going to divide the range of the data by the number of classes that you decided to select and round up. Okay? So to figure out your class width, you're going to take your range, you're going to divide your range by the number of classes, and then round that number up. More than likely, it's going to be a decimal, so you're going to round up. Okay? Then you're going to find your class limits. You're going to find your class limits after that. And to do that, you're going to use the minimum data entry for the lower limit of the first class. Okay? So you're going to use the minimum data entry for the lower limit of the first class. And then you're going to add the class width to the lower limit to find the next lower limit of the next class. And you're going to repeat this for every one of your classes. So you're going to find that, take that minimum value, and just continue to add the class width to get the lower limits of the next classes. And you're going to do the exact same thing for the upper class limits. Okay? You're going to do the exact same thing for your upper limits. Because you got your lower limits, and then you're going to need to have your upper limits as well. Then, of course, you can use tally marks for each of your data entries to determine how many data points fall in each class. But remember, that tally part, that's optional, okay? Because you can kind of spot it. You really don't have to do it again. It's just a quick way to get your data down. But then, of course, you're going to count up all your tallies to find the frequency of each class, okay? So just like with your frequency tables, you're going to have whatever you're dealing with, whether it's badmintons or if it's times or the shoe sizes, and then you're going to have your frequency in your other column. So we're going to take this first one. This is the very first simple example, just to make sure everybody kind of gets those steps. Because again, for your homework, you're going to have to create your own frequency distribution. Okay? So it says to construct a frequency distribution that has 3 classes for the age at inauguration of the first 30 presidents of the United States. And all 30 are listed for you. What's the number of classes?
30. Wait, what? 30, yeah.
Try again.
Oh, 4. No, 3.
It's 3. Because 1, it said to construct a frequency table that has 3 classes. Okay?
Sorry.
Like this one actually told you how many classes you're going to have. But again, when you do your homework, you are going to decide how many that you have. Please do not do 3. You have 60 pieces of data, okay? No less than 5, no more than 15, but I'll let you guys choose your class size, all right? What is the minimum data entry for our data? What's the smallest age that somebody got inaugurated into?
47.
42.
Look through your whole data. It is 42. 42. Second row towards the end. What's your maximum data entry? Who was the oldest to get inaugurated in? 68. Good stuff. Okay? Now you need both of those. You need your minimum value and your maximum value because in order to find your class width, you guys remember what it said on the other page?
You have to divide the range.
You got to divide the range by
the number of classes.
the number of classes. In order to get your range, you need to take your max and do what with it?
You subtract your min.
So you do 68 minus 42, get your answer, and then divide that by 3 because we're doing 3 classes. And what do we do with that number?
That's your width.
You
You round it up.
round it up. So what's our class width? It is 9. It is 9 because I think it was like 8.3 something. So you got to round up. So we got our number of classes. We found our minimum and maximum value. We found and the class width. So now we're on step 3. We have to find the class limits. So from the previous slide, it said that we got to use the minimum data entry. What is the smallest data entry here? 42. We're going to take that and we're going to add the class width to it to get the next lower limit of the next class. So what's 42 plus 9? And then we're going to do it again. What's 51 plus 9? So these are your lower class limits for this frequency distribution. Everybody following along? Okay. Now we got to get the upper. Okay. If the class width is 9, what's going to be the upper limit of the first class? 50. Okay. Plus, it can't overlap with the, it couldn't be 51 because then it would overlap and you wouldn't know where to put the 51. So it's going to be one less. And then you continue to add 9. What's 50 plus 9? 59. And then what's 59 plus 9? 68. You're not adding it to your lower limit. You're literally adding it to the previous upper limit. Yes?
Where did you get 50?
50 came from this particular value. The upper limit of the previous class is going to have to be 1 below it. It couldn't be 51 because, again, if there was an age of 51 in here, you wouldn't know to put it with the first class or the second class.
How did you get 51 again? You subtracted and then divided by 2?
We added 9 to each one of those values, which was our class width.
Okay.
All right? So now we can fill everything in, right? Because now that we have our ranges, now we're looking to see, okay, how many presidents were between the ages of 42 and 50 inclusive from the first 30 presidents. So you go through your data and you figure out how many presidents that was. I'll check back in a minute. So how many presidents were between the ages of 42 and 50 inclusively?
7.
8.
What's wrong with you?
It is 8. So we are including 42 and we're including 52. So if I go along my first row, that's 49, that's 50, that's 42, 47, 49, 46. Oh, and I sure did miss a 48 there, and I missed a 50 in between. And that is 8. How many were between the ages of 51 and 59? 17. And how many were between 60 and 68? 5. And we should, when we add them up, how many is that?
30.
And it should have been 30 because we have 30 presidents. Okay? So you can always check yourself, because if you miss something, you can always go back and realize, okay, I messed up somewhere. The number's not 30. Yes?
Will they always give you like the value of like 30 presidents so you can check, or we have to like?
If they don't, then it would be probably a small enough amount of data that you can count it.
Yeah.
Like the packets one. Like, I didn't have to tell you it was 24. You could have counted how many entries there were. But if it's a large amount of data, they're going to tell you. Okay? So like this one, Lonnie made 30 phone calls a week. So we know that we have 30 pieces of data. So our total of our frequency should add up to be 30. And the times of the calls in minutes were recorded. Okay? Now, I know I didn't use the best font, but that is a 3.1. That is a 1.2. That is a 17.3, and so on and so forth. Okay? I know the decimal's kind of hard to see on the copy. But we are going to organize this information into a group frequency table. This is one that we're going to make ourselves. Okay? It's the same thing you're going to have to do with your homework. Okay? So, decide how many classes do you want to have? Let's decide a class. How many classes do you want to have? How many groups? 3. Now, the rule is that no less than what? 5, no more than 15. So pick a number.
10.
I heard a few more 6s than the 5s.
10.
Okay. So we're gonna go ahead and as a collective, our class size is gonna be 6. Now, when you do your own or your homework, you decide how many classes you want. Okay. So our class size is 6. That's the first step. Now the second step is to do what? Find the max and min. So don't shout anything out. Look at your data.
Okay.
You're looking for the min and you're looking for the max. What's the min? 1.2. What's the max? Cool. So we need the min and the max because we have to find what next? The range, okay? So that means I'm going to do 35.4 minus 1.2. 34.2, and I'm going to what? Divided by the classes, which is 6, because I need to know how big my groups, my classes, my intervals are going to be. And we're going to round up. What's 34.2 divided by 6? 5 point something? 5.7. So my class width is going to be, it's going to be 6. That's kind of nice. 6 classes with a class width of 6. So now we got to create our table. Okay?
What did you put the bottom of the class column in the one before?
You don't put, you put total. All right? I'm going to go ahead and make this like a true frequency table. Again, like I said, it's usually only 2 columns. The first column is actually dealing with your data, and you want to label it. What are we going to label the first column?
Class number calls.
Not the number of calls. Well, actually, yes, it is the number of calls. Sorry. No, it's not the number of calls. It's the number of what?
Minutes.
Number of minutes. Okay? Because in this one, this is actually a specific example, so we can actually label it with what we're actually doing. And you need to do the same. I need to be able to distinguish which one is your heights and which one's your shoe sizes. So I need you to distinguish between the two for your homework. What goes in the second column? The frequency. It's always the frequency. Okay. Now with this one, we have some decimals. Okay. Some calls lasted 0.2, 0.1, 0.6, 0.4. Okay. And so, for the sake of simplicity, can we use whole numbers? Okay. So if 1.2 is my minimum, what's going to be my lowest class? Lower limit. It's going to be 1. So from there, I need to determine what the lower limit is of each of my 6 classes. Okay? Yeah, 6. So 1 is the lower limit of my first class. What's going to be the lower limit of my second class? It's going to be 7. Because you add the class width, which was 6. What's going to be the next one? 13. The next one? The next one?
25.
The next one?
31.
Okay. Now, we have 2 examples already. The one with the presidents and the very first one that we did that has the dash used to represent your intervals. Okay? Not everyone is going to be like that. Some are going to be written as a compound inequality. Okay? Some are going to be written as a compound inequality. Because look at your data. You have times that are 0.2 and 0.4 and things like that. So if I were to make the upper limit of my first class 6, that means the call that was 6.5 has nowhere to go. Okay? So in those cases, a compound inequality set up with your classes is a lot better. So you write your compound equality like so. Less than, we'll just use x, less than 7. Okay? So I have a less than or equal to with the 1, and then I have a less than 7. So my first class includes 1 and goes all the way up to 7, but doesn't include 7. So anything that's 1, 2, 3, 4, 5, 6, 6.1, 6.2, 6.3, all the way up to 6.9 is included in that first class.
Did you put 1 to 6.9?
No, I put to 7. So just in case if there was like a call that was like a 6.95,
Oh, okay.
it's still included in that first class. So we're going to continue that on with the rest. It's still going to be that same setup. Less than or equal to x is less than, all the way down. And then it's going to just be, bless you, the class limits. Okay. What about that last class?
37.
It's going to be, now you're not going to put the max. You still go with the width because it's still counting up by sixes, right?
Yeah.
So the last one's going to be 37. Fill in the frequency. How many calls were between 1 minute inclusively up to 7? Go through. Do that now.
Me too. That's what you get.
Which one?
13 or 12? 13.
Oh,
Caitlin!
First
You missed this one. Did you get the 5.5? Looks like 55.
Oh, I got that one. Oh, well, there's 13.
Yeah.
I don't know if you got it.
You're missing one. Let me see.
Did you circle?
Let me see.
Circle, square, rectangle.
Yeah, it looks actually.
You just circle each one and then.
I just crossed them out and then like went over and counted them.
She like hearted and like different shapes for each one.
Put different shapes around them and then I count the shapes. Did you get 13 or 19?
I think I like that. Sorry.
13, 19.
Oh, I got 13.
You have 13.
It's like cheese.
Did you check your totals to make sure everything added up to be 30?
Yes, we did.
Did you get 13, 6, 5, 2, 2, 2?
Yes.
So there you go. Questions on this?
What does that thing mean?
Some. All right. Now, a majority of your frequency distributions, your group frequency tables, will be compound inequalities. Okay? The majority of the ones, if they are a grouped one, they will be compound. Okay? Because from there you do histograms and cumulative frequency curves and box and whisker plots and all those types of other visuals with those types. Okay? So we're going to do one more. Okay? We're going to do one more. And this one is a question that says the table shows the number of pairs of shoes of each size sold in a shoe shop in one day. You got to write down the upper boundary of the first class and the last class, and then the lower boundary of the first class and the fourth class. Okay? So the first thing is you got to identify where your classes are. Your first class is which one? 15 to 19. Your fourth class? 30 to 34. And your last class, of course, is the one at the bottom. Okay? Now, your upper boundary, this is going to segue into what we do on Thursday. Your upper boundary is basically the highest value of your first class, and it's also going to be the highest value of your last class. Okay? Now, if you look at your classes, you see how the first class ends in 19, but the second one starts at 20. Okay? Whenever this happens, okay, your upper boundary, to find it, you take the upper limit of the class, which is 19. Then you take the lower limit of the next class, which is 20, and you find the average between the two.
Wait, that's to find what?
To find the upper boundary of the first class.
Wait, so how do we know that they're in the same class? So you put first, then you put fourth, then you put last.
Mm-hmm.
You said 20 is part of the second class.
Mm-hmm. But to find the upper boundary of the first class, This is the process that you do. So you take the first class, you take the upper limit of the first class, and then you take the lower limit of the next class, and you find the average, which is what? 19.5. You get that by just adding 19 and 20 and then dividing by 2. So that means when we are going to be finding or drawing our histograms and things like that, that is the value where our first class is going to end. It's not going to end in 19. It's going to end in 19.5. All right? Now for the last class, you do the same thing. To find the upper boundary of the last class, you take the upper limit of your last class and then the lower limit of the following class. Now granted, there is no next class, but if there were, what would this number be? 45. And then you do the same thing. What's the average between 44 and 45? 44.5. And that's how you find your upper boundaries. Lower boundaries work in the same way. To find the lower boundary of the first class, you take the lower limit of your first class and then the upper limit of the class before it. Now there's not one, but if there were, what would that number be?
14.
And you do the same thing. You take the average. What's the average between 14 and 15?
So it'd be like the upper boundary of one.
Mm-hmm. And then the lower boundary of the fourth class. You take the lower limit of the fourth class, which is 30. Then you take the upper limit of the class before it, which was what? And you find the average between the two, and it's what? 29.5. Now this skill is going to be beneficial when we're doing our histograms, which we're going to be talking about on Thursday. You need those upper boundaries and those lower boundaries when you're doing histograms and cumulative frequency curves, which are coming up. Okay? But we've classified our data. You have two different types. What are the two different types of data that you have? Qualitative and quantitative. Under quantitative, which is numerical, you have two different types, which is what?
Discrete.
Discrete and continuous. Discrete is what?
It's counted.
It's counted. Continuous? Measured. Okay? Then you have random samples and bias samples. Frequency tables. They're the ones that just list the numbers out with their corresponding frequencies. The total should always be what? The total, though. What's the total frequency? Not all the widths. It's all the frequencies added up, and that number should always be what? Should definitely be a whole number, yes.
It should always add up like to the table.
This should be the number of things, the number of data, the amount of data that you have. Okay? Grouped frequency tables or frequency distributions. Okay? Again, there's two different types. You have the type, like this example, where you have the dashes. Okay? That don't include a certain range of numbers. But then you have the compound ones that include all the numbers in between. For your homework, you need to do the one that has the inequality, because some of you guys have heights or shoe sizes that are a half. I'm pretty sure somebody gave you a 7.5 or 9.5 or something like that. Definitely do a compound frequency table. Okay? Questions on this? Yes?
What if when you were collecting data, you automatically kind of rounded past the whole? That's what I did.
All right. We'll talk about that.